Welcome to another video in this mobile application development learning series. I am Ghanashyam and I am the head of technology and ecosystem enablement at Beahead Private Limited. In this video, I'll be giving you a brief introduction to the Android NDK architecture. I will be talking about the Android native development kit, how to install the Android NDK, how to build the native libraries, and also I'll be showing demos of the same. So Android native development kit. Android Native Development Kit or NDK. It is a set of build scripts or toolkit which is required to incorporate native code in Android apps. The Android apps, that is the Java code, will call these native codes via JNI. JNI is Java Native Interface. So when to use NDK for app development? You should use NDK for app development when you are looking for performance. If in case your application has a complex algorithm or your application is targeted towards multimedia or if it is a game, then NDK gives you a better performance. Also, if in case your application is using any CPU specific optimization techniques, in that case, NDK applications is preferred. So does it mean that we have to use NDK at all times? No, you need not use NDK application if your application does not include any complex algorithm or it does not include any multimedia specific operations or if it is not using any CPU specific optimization techniques. There is an overhead which NDK puts into, so in simple applications NDK should be avoided. Now let's look at Intel platform support for NDK apps and Dalvik apps. The Dalvik apps just work whether it is an Intel architecture or a non-Intel architecture. The Dalvik apps, since they just use the Dalvik virtual machine and Dalvik virtual machine is the part of the Android architecture, it works. It is platform independent. Whereas in case of NDK apps, many NDK apps which are targeted towards non-Intel architectures run on Intel platform without any recompilation. However, the performance improvement is not guaranteed. You might see a lag in the application. Intel has started providing NDK support or NDK toolchain since 2011. So the best option is to compile the non-Intel NDK app using x86 toolchain to make it work with Intel architecture. Another thing to be noted is that if there is any specific processor dependent code which is targeted towards non-Intel architecture, then the code porting may be necessary. As of now, Intel has validated and tested most of the top Android market NDK apps and the top Android market Dalvik apps, and it is found that they've worked successfully on the Intel based devices. So now let's look at the cycle of the NDK application development. This is the sequence. First you write the C++ code, then you have a makefile, and this makefile we are specifying what is the target which the application needs to be built to, what is the processor what is the platform this application needs to target to, using the flag app_abi. We use the NDK build command to build the shared object libraries or the SO files, and then the Java program uses these shared object libraries and calls to the native functions through JNI. First, we create the Java native library. This is automatically compiled with Java C into a Java class. Once this Java class is ready, we'll use the Java H. There are two methods how we can write the native code. One is a Java H method and the other one is the JNI onload method. First, I'll be talking about the Java H method. Using the Java H function, you will take this Java native library class and create a header file. This would be a C header file, and using this C header file you can link your C or C++ code. Once the C++ code is ready, we will use the application ABI flags and the makefile to create the shared object library or the dynamic library. So we use NDK build command to create this dynamic library. So this is how the NDK libraries are created. So this whole process of creating header files and linking with the C++ code can be eliminated using the JNI onload method. I will be talking about both these methods in detail in the next slides. Let us look at installing NDK. So NDK needs to be downloaded from the Android side. You choose the correct version of NDK for your system and download it. So what NDK provides, it provides the build environment, it provides the headers and libraries required, and also it provides some sample files as well. Now let's look how to include native codes to an existing Android project. In a manual method, what you need to do is first you need to create a JNI folder under the project folder, and all the native functions or the native files, the C++ files, including a makefile, Android makefile, needs to be present inside this JNI folder. So once JNI folder contains these files, you can use the NDK build command to create the libraries and the shared objects. The NDK build will automatically create the platform specific libraries under the libs folder. Now let us look how to add NDK support directly in Eclipse. In Eclipse, right click on your project, select Android tools and click on add native support. So once you click on add native support, automatically and Eclipse will create you the C++ file as well as the Android make file. Now let's see how to build the native libraries. As I was talking in the NDK platform slide, the first thing what we need to do is we need to create Java native library and then compile it to create a Java native library class. When creating the Java library, we need to declare the native methods using the keyword native. Another thing we need to do is to load the shared library in the application. This can be done during the class load using this block of code. It should be encapsulated under static. We have to use system.load library and the file name. As I was talking, there are two ways to associate the native code with Java method. One is the Java H and JNI onload. Now let us look at the Java H method. Java H method automatically generates an appropriate JNI header stub based on the Java source file. That is, it takes the Java class as the input and creates the header file which can be used by the C or C++ file. Here is a small example. In hello.jni.java we have java.setText string from JNI. So string from JNI is a native function which is defined in the C function, C file, that is in hello.jni.c. The other method is JNI onload method. It is preferred that we use JNI onload method compared to Java H method for the following reason. It is a proven method. What do you mean by proven method? It is what the Android open source platform is built on JNI onload method. In case of Java H method, the native functions needs to have a specific naming convention. Any small changes to the naming convention, you will be able to identify the mistake only during runtime. Whereas in JNI onload method, you will have no such surprises. It will also help you to maintain your native code easily. Since there is no naming convention which needs to be used, you can name the native functions however you want. Here is an example for JNI onload method. We have string from JNI function defined, and after we define this function, we have a JNI native method array type which contains all the native functions which have been defined in this particular file. It contains the name of the native method, the return type of the native method, and the parameter input, the type of parameter input. After we create the JNI native method array, we need to now register the functions, register the native functions, how it has been called from the Java class and how it has been implemented, or with what name it has been implemented in the native code. This is the standard JNI onload method, how it looks. First we are getting the environment, the JNI environment, then we are finding the Java class, we are taking a reference to the Java class, and once we take to the reference to Java class, we are registering the native functions. So in the previous slide we have seen that expose method is JNI native method, is an array of JNI native method class. So here we are registering that particular, that we are registering the functions which are present in that array. Java H and JNI onload are the different methods how you can create the native libraries, or you can write the native code. The next thing what we need to focus on is how to build the NDK. Building NDK libraries or building the shared libraries, shared object libraries is very simple. It is just an execution of the NDK build command. This NDK build command looks at the application.make file if it is present as to what platform are we targeting towards, or we can directly specify the target platform type next to the NDK build command. Let us look at a demo now. So I have downloaded the Windows NDK file from the Android NDK site. I have downloaded the 32-bit version. The installation is very simple. As the Android SDK installation, even this is just unzipping the files. Let me go ahead and unzip it. So now that the NDK has been extracted, NDK files have been extracted, I'll go ahead and open Eclipse. So the first thing which I'll do in the Eclipse is to provide a link to the NDK. So go to Windows, Preferences, go to Android, click on NDK, and I need to specify the path where NDK is present on the machine. So I will give C Android NDK. Okay. I have already created a NDK project, so just let me import the project. So while I do the other activities, I'll also go ahead and run a emulator, start the emulator. While the emulator is starting. So this is the Java native class or Java class which I have created. The scom.sample is the package name and fiblib is the class name. So see here, there is a Java implementation, recursive implementation of Fibonacci series, and Java iterative implementation of the same Fibonacci series. I have two native functions which I want to use in this particular application. One is native fibn, that would be a recursive version of a native function, and fibni, that is a iterative version of the native function. Okay, so let me minimize the emulator. So once I create this class, fiblib class, Eclipse automatically builds the class for me. So the next thing which I need to do is I need to go ahead. I'm using the Java H method. So in the Java H method, what we are going to do is so in the Java H method, once we have the Java class, we have to go ahead and use the Java H function to create the header file. So let me do that. Java H hyphen JNI. So hyphen JNI is an optional parameter. Java H function by default takes the JNI, like it creates the JNI header file, but as a good practice I maintain hyphen JNI. Then the output directory will be JNI folder. The file has to be created from my Java class com.sample.fiblib. So it has created the header file for me. So see the naming convention here. It is a JNI export. By default it gives you that JNI export keyword, and look at the return type. It has provided me JInt. The reason is the size of data types between C++ and the size of data types in Java is different. So in case of NDK applications, we have a special data type for the native functions, which is similar to the size of the data type in the Java class. So int becomes JInt, long becomes JLong, and etc. So see the function name, it takes Java, then it takes my package name com.sample. It also takes my the class name from which this particular header file was created, that is fiblib, and finally it has the function name, that is fibn. Similarly, Java com sample fiblib fibni. So this is the recursive version of the native function, and this is the iterative function of the native function. From this particular file, I'll create my C file. So in the C file, you can see that we are including the header file which the Java H function created, that is the com sample fiblib.h. We have the definitions for the functions Java fibn and fibni. So now that we have our code ready, the next thing what we need to see is we need to build our make file. So that is the android.mk file. So in the android.mk file, these are the variables which it needs. It needs the current local path. This is a standard statement which is used in the android.mk file. Then we are clearing all the variables, so that is the reason we are including clear vars. The local module, so what is the output file name? So output file name will be fib.so, so that will be the local module name, that is fib. And which are the files it needs to compile? For now it needs to compile just the C file. If in case you have multiple files, you need to specify all the files in this particular variable. Once we have the make file and our code ready, we'll go ahead and build the shared object. So let us do a NDK build. NDK build by default takes ARM as the target platform. I think it was already created, so let me clean it and create again. So you see that it has created it has created shared objects targeting the ARM platform. So if you go to the libs folder, we find that it has created ARM EABI and libfib.so. So what we have completed now is this part. We have taken the Java native library, we have compiled it, we have created using the Java H, we have created the C code, and from C code we have created the shared library. The next thing what we need to do is we need to load this particular library. So if you see the fiblib, you can see this native implementation, this part. Here we have specified we are loading the library, system.load library fib. So you remember in the android.mk file, we specified the module name. So this is what you need to load in the Java library. Let us run this application. Let me enter any value here, for example 10. Go. So you can see that the Dalvik recursive took 32 milliseconds to execute, whereas the same code when it was in native it just took 1 millisecond. This is just an example where we are trying to show that the native applications or the algorithms when implemented in native code will improve the performance of the application. This was the Java H implementation of creating shared libraries. Now we look at the Java JNI onload method. JNI onload method is primarily used when when the native code is present in C++. What I have done here is I have copied this fib.c file into a fib.c++ file and I have made some changes. The first changes, I have moved all the code into a namespace fib. The remaining functionalities remain the same. The next major change what you can find is I have changed the function names. You can see here it is just jint fib and jint fib and niter, whereas here it was a long name. It had to have the Java as compulsory, the package name, the library name in Java, and then the function name. So here I can use whatever name I want. And the next thing what we are doing here is we are creating a Java native method array table. It contains the fib n and fib ni. Fib n is the function name in Java. Fib is the function name in C++. So this represents the return type and the parameter. So the I in the bracket represents that it takes input as a integer. So that is the jint n, and return type is also jint. So that is the another I we have specified here. Similarly, I have another entry for fib ni. Fib ni is the Java name. Fib niter is the C++ name with the return type integer and the parameter integer. So here we have created the method table. Finally, what we do is the JNI onload. JNI onload registers the native function. So first I get the reference to the class in Java, com sample fiblib. If you see here, instead of com.sample, I have taken it as a path, so it becomes com/sample/fiblib. And once I get the reference to the class, what I do is I'm registering the native function. So the native function is already loaded in the method table array. So I'm calling the register native function to register these function names. Finally, I'm clearing the memory, I'm deleting the local reference to the class. To make this file, what I need to do is I need to go to my android.mk and instead of source file as fib.c, I'm changing it to fib.cpp. Save android.make file. go to the command line. Let me first clean the existing code. So I have already cleaned. So if you see the ARM EABI contains no files. So I will go ahead and do an NDK build again. So the shared object library is created. Now let me run this application again. I'll give the same input and so this is the result. With this, we conclude the second video in this series of mobile application development. In this video, we have understood what is Android NDK or Android Native Development Kit, the installation procedure of NDK, how to build the native libraries. We have seen two different methods. One is a Java H method and the other one is the JNI onload method. If you have any questions about this module or this video, you can email us at intelapps@beahead.biz. Thank you.